what is meant by an antiderivative? So, for most of the calculus course that you would be taking, you would have been finding derivatives and learn numerous derivative situations and derivative rules. But what we're doing here, suppose that we do already have a derivative, and we're going to ask, where did it come from? What was the original function? So for instance, for the first example, if the derivative of a function is 8x to the third minus 3x squared plus 10x plus 5, what is the original function that had this for a derivative? So, in a sense, we're going to be using the derivative rules in reverse, thus being called the antiderivative. So, thinking to ourselves, what would the original term be that would have given you that portion of the derivative? So you remember that for the product rule, you were multiplying by the power and then lowering the power by 1. So you would think that if you went in reverse, you would have to raise the power by 1. And so for 8x to the third, if the power goes up by 1 and becomes 4, then the 4 would have been multiplied in order to give you the 8, so the original coefficient must have been a 2. And you could always check by taking the derivative and seeing the derivative gives you that portion of the derivative here. So multiply by 4 gives you 8, drop the power by 2 to the third. And then for the next term, again, you figure that the power would have gone up by 1, x to the third, and then in order to have 3, you would have had to have multiplied by that 3. So simply, the coefficient being 1, and you have that portion of the antiderivative being simply x to the third. And then for 10x, you figure the x would have come from an x squared. So therefore, instead of having a 10, you should have started with a 5, because then multiplying the 5 by 2 would have given you the 10. Again, mentally, you're doing the derivative in reverse. And then what is it that would have had a derivative of just a 5? Well, that would have been a 5x. All right, so it appears that this is the antiderivative of the derivative 8x to the third plus 3x squared plus 10x plus 5. But is that all? Remember that when you took derivatives, you may have also had a constant term whose derivative would have been 0. So in general, when we find an antiderivative, we want to write down plus c to indicate that we might have had a possible constant that could have had that for a derivative. Thus, hinting the idea of this concept of being indefinite, that there's actually an infinite number of functions that could have had that for a derivative, because there's an infinite number of possible constants that that original function could have had. So in the next example, thinking through our derivative rules, what is the original function that had e to the x plus cosine of x as its derivative? Well, e to the x, we know, is its own derivative. So therefore, its antiderivative should also be e to the x. And then think to yourself, what is the function that has cosine for its derivative? Well, sine has cosine for its derivative, sine of x. And then this, like any other function, could have had a possible constant whose derivative would have been 0. So again, we want to indicate plus c. All right, for the third example, we have 5 over x squared. So really the best way to think of this is actually 5x to the negative 2. And think, what would the power have been in order to give you a derivative of x to the negative 2? Remember that this is a power that would have dropped by 1. So going in reverse, going up by 1, you figure that the x would have gone from negative 1. And then if you multiply by the negative 1, you should have actually started with a negative 5 here. And then we can write that, of course, as, if we'd like, negative 5 over x. And as usual, it could have had a possible constant whose derivative would have been 0. So, the notation for this is what we refer to as the indefinite integral notation. So the symbol there that looks like somewhat of a musical note symbol is the integral symbol. And the integral would indicate that we are finding the antiderivative of that function, meaning assuming that it is a derivative, what's the function it would have come from. And the dx for right now is an indicator that we are finding that integral in the variable x. Now later on, when you use this for geometric concerns, the dx will actually have a geometric notation. So therefore, our notation is this indefinite integral notation, written like this there with the answers that you would have had for all three examples, written in interval notation.